Okay, we've all seen spreadsheets like this. Here's one that's keeping track of company revenue. Revenue comes from hardware, software, service, and licenses. Looks like services makes most of the money, $2.1 million out of the $3.4 million that's grossed. And it's not uncommon to add another column that's a running total. As you can see, hardware is the first line item, so there's $784,000. There is an additional $97,500 if you count the software, which gives us a running total of $882,450. And the totals get bigger as you add each line item. And the last line item is equal to the grand total of all of the revenue. Now, there's another possibility where we kind of have a percentage running total. In other words, hardware is about 23% of the $3.4 million. Hardware plus software adds to 26%. Finally, when you get to the last line item, you've covered 100% of your revenue. SQL 2012 has a number of analytical functions where the function will use values from other records to get its answers. Let's start off with a really easy example. Here's all of the locations in order by location ID. Now, we're going to do a cumulative distribution, which is kind of like a running total. And we're going to put that as an expression field. Let's, in the select list, put comma, CUME_DIST, and a set of parentheses. Now, after that, we're going to put the over clause. What are we going to put there? The order by clause. And let's run that. And here we go. Now, we have 6 locations. That means each location represents 16% of our locations. So here we see 16, 33, 1/2, which is 0.5, 66, 83, and finally 1. That's kind of like a running total. Cumulative distribution is very, very similar to another analytical function, and we're just going to change the word cumdist to %_rank. Let's run that. %rank starts the first record off at 0. After the first record, location 2 represents 20% of what's left, 40%, 60%, 80%, and 100. Let's look at all of the records of the employee table. We've got a lot of different hire dates. Let's find out who was hired first by doing an order by hire date. And run it. Looks like Sally Smith was hired first. She's back in the 80s. Here's 2000s. And Sue Fines is our most recent hire. Okay, there's another way to find the first hire. Let's put comma, first, value, and then say hire date. And we're going to say that's over. And we're going to cut and paste the order by in the over clause. Let's run this. The first hire date is listed next to each person's record. What if we wanted to find the most recently hired person for location 1, the most recently hired person for location 4, and the most recently hired person for location 2? We can do partition by location ID and run it. Now let's see what we got. Who was the most recently hired person for location 2? Well, we don't know, but we know that they were 1999, which apparently is Leo Sacco. How about for location 4? Well, it is 1995 on May 26th. Here's our state list, which contains a list of states and provinces, and it's sorted by largest to smallest. Alaska is the biggest, Quebec's a little smaller. Alaska is how much bigger than Quebec? Well, whatever 656,425 minus 523,603 is. Is there a way we can list the leading states next to the trailing states and have these two comparisons side by side? Yes, there is. Watch this. Let's add an expression field that uses the lead function, and in the set of parentheses, choose landmass, and then put a 1 right here. And that is over the landmass in order by descending landmass. Cut and paste the order by clause into the over. Now, this is the landmass for Alaska, and notice Quebec's is listed right next to Alaska on the first line. Let's go ahead and alias this field as next landmass. Okay, here's the landmass for Alaska, and here's the next smallest state or province. Well, what is the difference between these two sizes? We can actually calculate that. Let's add another expression field, and then let's say landmass, which in this case is Alaska, and we're going to subtract the lead of the landmass, which is Quebec, by using the expression field. Basically, Alaska is 132,822 square miles larger than Quebec. We probably want to alias this field to give it some meaning, so let's put as size diff. That looks a lot better. Let's look at all the customers in order by customer ID. Now, Lee Young is customer number 2. Well, who's the previous customer? In other words, who is the customer that lags by 1? Well, the customer who's previous to Lee is Mark. But let's show that by doing lag, and then choosing first name, and then lagging by just a row of 1, and saying over, and then put in order by customer ID. All right, let's run that. There. We see that Lee got Mark, Mark has nobody in front of him, Patricia has Lee, and so forth. Looking at the grant table, we can easily see the largest and smallest grant because, well, it's sorted by amount. But what is the median grant? Well, that's the one in the middle. The median grant here is at $19,000. We're going to add an expression field that says percentile cont 0.5, which is the median, within the group order by amount over, and let's run that. And we see we get 19,000. That's the median grant. That was a 0.5 median. What does a 0.6 median mean? Now it's 22,100, because that's the median offset by 0.6. Here, we have a double-level sort. In other words, all the long-term category stays are in one group, and within that group, we've got the highest, second highest, third highest by retail price. And if we scroll down to about record 80 or 160, product ID 486 is the highest price median stay, and product 481 is the second highest priced. Now, what we want to do is find the median price for long-term stays, the median price for the medium stays, the median price for the no stays, and the median price for the overnight stays. To do that, let's add an expression field and then use the percentile_cont function. We'll put 0.5 to get the actual median within the group, and we're going to order it by the retail price. We're going to say that is over the partition of the category. Let's run this. All right, the median price for long-term stays is $499.15. The median price for medium stays is $273.638. And the median price for no stays is $78.949. And overnight is $142.1082. Lab 1.3, Skill Check 1. From the JPro Code database, show the amounts from the grant table and the lead over the next amount in order from highest to lowest. The Amount More field should show the difference in value from itself to the value of the next lowest grant. When you're done, your results should resemble the figure you see here. Skill Check 2. From Skill Check 1, use the is null function on the Amount More expression field so that the last value is not null, but uses the total value of the grant. In other words, the $4,750 grant should not be null, but should use its own value. Skill check 3. From the JProCode database, use the percentile_cont function to show the median amount of each class next to each record in the management training table. Skill check 4. Take the results of skill check 3 and create an extra time field that shows how many hours over or under each class is. Sort the results by highest extra time. When you're done, your results should resemble the figure you see here.